So it used to be when you create an ext2, 3, or 4 file system, the check interval would be set between 20 and 40, just a random number between 20 and 40. And essentially what that would mean is, actually, I take that back. It was a number of days.
Yes.
And I don't remember what the default setting was. And
Yeah.
so what would happen is you would have this thing running for a year, and then something would happen, a data center power outage or whatever, and your machine would boot back up. And because the check interval, the file system check had not been executed within however many days, it would go ahead and do one automatically at boot time. And the other one that would trigger this is this setting right here. That's the one that's normally set between 20 and 40, which is if the file system had been mounted and unmounted this number of times,
Right.
that would also trigger an automatic fsck the next time the system was booted. The problem is with automatic fsck's is that they're not generally needed. So
Right.
here you are,
And
you've just had some kind of like unexpected thing like a power outage, and now you're waiting for your system to boot, and it's stopping
for
booting
what
to do all
reason? Yeah. And
right.
there was a point where these were considered best practice. That's the reason they were in there as the defaults, right? And there was a point, especially in the ext2 days, where they were probably a good idea, right? This thing should be checked every so often because it doesn't have a journal. Now that we have journals, though, not such a big deal, right? I can remember back in the days when I was running servers, there were certain systems that had really large file systems that were specifically there for file storage, where you'd be like, okay, we have to do maintenance on this machine, we have to reboot it. Someone has to be there to make sure that it doesn't auto file system check at the reboot time.
Yeah, and you can actually turn these off with tune to FS, right? So
Yeah.
it's now
Yeah.
the default. Whoops. It's now the default, but if I tune to fs dash I, that's the interval, and I set it to 0 days, that means turn it off. And C, that's the maximum mount count. If you set it to 0 or -1, that'll turn it off. And that'll take care of it. So you may want to check other file systems, or I know that in RHEL 8, as an example, I think it's still set, if you're creating file systems with MKFS, it would still set a maximum mount count and interval automatically, but we've now changed it to be more sane for ext4 file systems. All right, so Shantanu points out that he's needed to force an FSCK when parts of the file system start having weird errors.
I was
mean, you
typing
could
a
all
response to that when you noticed it.
boot the machine to rescue and just FSCK it from there,
Yeah. Yeah. But
rather than
I
like.
I guess if that's in reference to my statement that you shouldn't need file system checks because of the journal, there's always those edge cases, right? And that's why that's why the tools still exist. That's why there is an XFS repair, because we know, or the people who wrote the file system know, sometimes you're just going to have to do a file system check, and therefore here's your tool, right? Sometimes that's going to be painful, though, like in the case of, no, you can't do that on a mounted file system. And that's kind of always been the case. You couldn't do that on ext 2, 3, or 4 either. Well, you could force the check, but it wasn't recommended.
Use -F and it would force it. The other
Yeah.
thing that, we used to use these tools to try and control fragmentation.
Yeah.
So what would happen is your data blocks would be stored not contiguously.
Yep.
And that would mean that things like the read ahead buffer that would automatically happen when you retrieved a block off of disk would grab a bunch of blocks that weren't associated with your file and were therefore useless to you. And so we want to
Right.
try and store files as contiguously as possible to try and take advantage of some of that automatic caching and automatic look ahead that we do when expecting that another related disk IO operation is going to be requested by the operating system. But ext4 and XFS both automatically kind of handle that as they're doing their regular file operations. If they see that the file is now larger and there is not contiguous disk space available in its current location to store it, it'll actually move it to another area of disk that is able to store that contiguously and then mark the old location for reuse so it can store other files in that place. So this
Right.
just like happens automatically through like file system operations now, which is
I
why
remember in
there's
my old like MS-DOS days having to periodically remind myself to go run a defrag, right?
right,
Because nothing did it automatically then.
right. And the other place where we used to do it is like your disk space was low and then you added disk space. So now you
Yeah,
had this giant pile of contiguous disk space, but because you were operating in this smaller, more constrained environment, it wasn't paying attention to the fragmentation. It was just like trying to store whatever it could store.
right,
But now, if you did that, it would just kind of automatically, as you access files, will figure out that they're fragmented and it can now store it in a non-fragmented way elsewhere in the device layout.
right.
So all this stuff just kind of works. So I see Eric asked if XFS repair feature is coming. It already exists. It's called XFS_repair. We're just
Well,
not running it. Number of
he's
things
asking if
are.
there's an online repair coming. I haven't heard of anything.
Oh, no, you unmount it just like you do fsck and then
Yeah.
run the repair. Let me check. There may be an option.
I mean, Linux usually gives you an option, even if it's going to make you regret life later. So it wouldn't surprise me if there's a please don't use this, but here's an option if you need it.
There's a -D repair dangerously. that sounds like
Repair dangerously.
oh,
Uh,
but yeah,
that sounds
like
about right.
when
Don't
your
use this
file system,
option.
yeah, when your file system check utility is like, hey, there's this, but you probably don't want it. You probably do not want it.
Right. Right. Dangerously.
Yeah, nobody cares
I
about
like
file
to live
systems.
dangerously.
What they
I
put
always
there
put
is
on the -D.
all right. So the other file system types. So ext3. That's still pretty common, especially if you have older systems.
Yep.
ext3 is also journaled, so just like ext4, but it doesn't have the kind of auto defragging stuff that ext4 has in it, where they allocate additional extent to restore your file in a non-fragmented way.
Right.
Also, it has limits on how many subdirectories you can have in a directory and what your maximum file size is, just because of like all the redirection that one could do with data blocks there, because it was really ext2 plus, right?
Yeah.
So ext2 is another one that I see occasionally when somebody wants something really small. In fact, I tried to format something as an ext4, and a very small, like 100 meg file system. Actually, maybe it's more like 2 meg file system. And I was like, nope, not enough space. Can't format as an
Yeah.
ext4. But you could format that as an ext2.
I've
And
seen, and I don't know if there's a real good reason for this, but I've seen in cases like micro systems like the Raspberry Pi, for example. Raspbian, I think, was for a while defaulting to ext3 instead of 4. I don't know if there was a reason because they're using SD cards instead of spinning disks or whatever, but the file size, or not the file size, the file system size thing is really the big thing I've seen ext2 used for occasionally, because it has a smaller footprint for the file system than a journaled file system does.
yeah, because we got to store the journal log. The other thing is like, how big do we make those inode and data block
Right,
chunks? That is bigger for ext4, and so that's why errors on those really small devices.
right.
The other one that we get questioned about a lot is NTFS.
Yeah. Yeah, there's cases where people need to be able to share, like say a USB stick, for example, or even a disk on a dual booting system. Like say this is your desktop and you're dual booting Windows and Linux, a file system that could be read by both. And the ext and XFS file systems ain't it, because Windows doesn't support those. Well, maybe it does now in the advent of the Windows
Resale.
subsystem for Linux stuff. But for a long time, that was not the case. Sorry, no ext file systems for you.
Yeah, and where I see it is like people want to use some of the extended attributes for Active Directory as an example. And you
Right.
can't do that on the ext file systems. So Red Hat doesn't ship a NTFS driver for RHEL, but you can get it from one of the extended repositories. I want to say it's an RPM Fusion, but it's been a while since I've looked.
Yeah, I can't recall where I got it the last time I needed it.
Yeah, but so you have to use one of the add-on community repositories in order to find it.
Right. I found VFAT to be probably a more interoperable and supported out of the box file system, but it doesn't have those extensions that NTFS does. But it'll be read by both Windows and Linux, and it has decent file system and file size limits as opposed to the older FAT file systems.
Which you could also just front it with a CIF surface. So if
Hmm.
you make the ext4 file system and then stick CIFs in front of it, Windows can then use the CIFs protocol to retrieve and store files. And that way you're storing it on ext4, but your Windows client has access to it, but you'll need like networking and other stuff to make that work.
Right, right. But in the case of like a removable disk, for example, where where you're going to plug it directly into a system and you don't have that luxury, then something like VFAT works pretty well.
Yeah. Shantanu references the NTFS is actually an Apple. So go
There you
us.
go. I couldn't remember if it was Apple or Fusion. So thank you.
Yeah.